wall using a piece of string 1 meter long. The ends of the string are tied to 2 points 0.6 meters apart on the same horizontal level on the back of the picture. Draw a diagram and use it to find the tension in the string. So if this is my picture frame, we've got 2 lengths of string. Oh, that's slightly too long. Again, 2 lengths of string. We know the weight of the picture is 50 newtons. The piece of string is 1 meter long, so the length of each of these sections is 0.5 meters. The distance between them here is 0.6 meters. And we're interested in finding the size of the tension in each of these pieces of string. Now I'm going to call them T1 and T2. By symmetry, we're going to find, of course, that they're equal to each other. I think it's easy if you label them both as T to forget that there's 2 of them rather than just one. So the first thing we need to be able to solve this problem is an angle. So the angle is going to come from a bit of geometry. I'm going to split this in half and redraw the triangle that I've now got on the right hand side. This has length 0.5 meters here and 0.3 meters down here at the bottom. I'd like to find the size of one of these angles. Doesn't matter too much which one I pick. My inclination is to go for this one because I know that this will also be the angle here, but it doesn't matter too much which one I pick. I could easily pick this other one. We can work through the problem in either direction. So I know the opposite side and the hypotenuse. If I labeled them adjacent, opposite, hypotenuse in this triangle. So I know that the sine of this angle, which I'm going to label as theta, is equal to the opposite over the hypotenuse, and therefore the value of theta is the inverse sine of 0.3 over 0.5. That's 36.87. I'm only going to answer my question in the end to 2 significant figures, but so we don't make a rounding error along the way, let's record this as 36.87 degrees. So then now I want to resolve the vector t. So t2 I've got is a vector acting in this direction, that's t squared. t2 is a vector acting in this direction with an angle of 36.87 degrees over here. I want to find the vertical component of it. I'm going to draw that over the top here. This is T2 vertical. This I can see is on the adjacent side of the triangle. So from this side, I'm going to get a force of T2 times the cos of 36.87 is going to be the size of T2 vertical component. I've got the vertical component from this side. I've got a second vertical component of the same size on this side. So I'm going to have 2 times T2 cos of 36.87 as my total upwards force. That has to be equal to 50 newtons, which is my downwards force. Not giving myself enough room as usual. So the size of T2, which of course is also the size of T1, so I'm just going to call it T. The size of T is 50 over 2 times the cos of 36.87. If you want to use the answer button on your calculator, that's fine. If you want to keep it as the inverse sine of 0.3 over 0.5, that's fine. This gives us a size of the tension of 31.25. We're just going to write it to two significant figures, so 31 newtons.